So, welcome to another segment of my chemistry videos, and we still continue looking at more concept. But this time, our focus is looking at how to calculate from a balanced chemical equation. So, I want just to tell you a few concepts that you need to appreciate. So, for example, we have a reaction involving hydrogen reacting with oxygen to produce what we are calling as being H2O. So hydrogen reacting with oxygen to produce H2O. Of course, we need to make sure that the equation is balanced. So if I balance up that, I know I can put up a 2 because there are two oxygen atoms. The moment I put up a 2 here, the hydrogen becomes affected. 2 times 2, that's a 4. So meaning that I need to put up a 2 in front of the hydrogen. And obviously, if I look at it, the equation is balanced. Now, there are a lot of things that an equation can actually tell you. One, it is able to tell you about what we are calling as being the mole ratio. So you can get the mole ratio from the balanced chemical equation. Now, what do we mean the mole ratio? Well, the mole ratio are simply numbers in front of the formula. So in front of hydrogen, what number do we have? It's a 2. So meaning there are 2 moles. What number is in front of the oxygen there? You can't see it, but there's a 1. So it simply means that there's a 1 more. And what number is in front of the H2 or the water? There's a 2 there. So meaning that you do have a 2 more. So from the balanced chemical equation, I can know about the mole ratio, meaning that 2 more of hydrogen reacted with 1 mole of oxygen to form or to produce, in this case, 2 more of H2O. So that's what you can get from a balanced chemical equation, the mole ratio. 2, a balanced chemical equation can also tell you about the reacting mass, the masses. So it can also tell you about the masses. In this case, I mean the reacting masses or the masses that are produced. So let me just say the masses. So it can also tell you about the masses. So from this equation, we can find the mass. Now, when you're finding the mass, you look at the total number of atoms that are there. For example, what's the total number of hydrogen atoms there? There are 4. 2 times 2 multiplied by the atomic mass of hydrogen, which is 1. So meaning this is the mass of hydrogen. It is reacting with how many oxygen atoms are there? There are 2 times the atomic mass of oxygen, which is 16. So this is the total mass of oxygen that was reacting. What was formed? Well, if you remember, I told you for H2O alone, you have oxygen and you have hydrogen. So oxygen is simply 1 times 16, which will give you 16. Hydrogen is 2 multiplied by 1, which will give you 2. So for water alone, 16 plus 2 give you 18. So meaning the total mixture for H2O alone there is 18. But how many water molecules are there? There are 2. So it will be 2 multiplied by 18. This is going to give me grams of H2O. So from the balanced chemical equation, this times that will give me 4 grams of hydrogen is reacting with 2 times that will give me 32 grams of oxygen. To form what? This times that will give you 36 grams of H2O. So again, you are able to know from the balanced chemical equation how many masses we are reacting and what we have formed. So from this balanced chemical equation, we know 4 grams of hydrogen reacted with 32 grams of oxygen to produce 36 grams of H2O. Of course, there are a lot of things. It can also tell you about the molecules. You can also talk about the number of particles according to Avogadro's number or constant. It can tell you. So there are a whole lot of things. But in most of the calculation, you'll be dealing with looking at either the mole ratio, comparing the mole ratio, or comparing the masses. Well, let me demonstrate by looking at a question that came in the ECZ exam and see how you are able to use up this. All right. So there's a question that I had written well in advance this side. Then you'll be able to see it. So it actually says there. So this is a sample question coming, that should be from, maybe if I'm not mistaken, from the 2022 ECZ exam. So it says, in an experiment to prepare a salt, Elena reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeter of dilute nitric acid of concentration 2.0 mole per cubic decimeter. So remember, you need to go back if you're struggling on how to write, formulas, chemical formulas, because that will help you. Notice the first part question, if we look at the solutions there, it simply says write a balanced chemical equation for the reaction. So it's a reaction between magnesium oxide and dilute nitric acid. So remember, magnesium oxide, that's the correct formula, magnesium oxide, it is reacting with the nitric acid is HNO3. When a base and an acid react, they'll produce what we are calling as being a salt. So you are going to have, in this case, magnesium nitrate. So magnesium nitrate plus H2O. My space is small, so that is what you are going to have. Remember, magnesium has a valence of 2, nitrate has a valence of 1. So crossing them, this is the correct formula that you're going to have. Now, of course, we can balance up this equation. So how do we balance up? I can see there are 2 nitrates there, so I can put up a 2 in front of the nitrate. Now, the moment I put up a 2 there, it simply means hydrogen becomes affected, which I've already seen is a 2. Then this equation is balanced. So that is what they wanted you to do in that first question. In the B part of the question there, B1, it says calculate the number of moles. So they want us to calculate the number of moles of 1 magnesium oxide. Now, if you notice, to calculate the number of moles of magnesium oxide, for magnesium oxide, they told you the pupil reacted 3 grams of magnesium oxide. That's what they told you. So how many moles are there? So first of all, you need to find the mixture of magnesium oxide. So you need to find the mixture of magnesium oxide there. Of course, magnesium, if you look at it, there's only 1 magnesium, so 1 multiplied by 24, the atomic mass, plus how many oxygen are there? 1 multiplied by 16. So this is going to give me 24 plus 16, which is going to give me a 40. If you want in molar mass, that would be in gram per mole. So that's the mixture or the relative molecular mass. Now, to find the number of moles, it simply means that I'm going to apply the formula. Number of moles is equal to the mass divided by the mixture. So we are talking about the mixture of magnesium oxide there. So how is it going to be? So number of moles will be, what's the mass? It was 3.0 grams divided by the mixture of magnesium oxide, which we found to be 40. So that would be 40 gram per mole. So this gram and that gram will cancel. So what will that give you? Well, when you look at, divide that on using your calculator, 3 divided by 40, that is going to give me a 0.075 mole. So this is magnesium oxide. So these are the number of moles that they wanted you to calculate for magnesium oxide. And that question was just carrying just 1 mark. All right, so that is what they wanted you to do. Then what about the B part, the number of moles for dilute nitric acid? How can we get that? Well, it's very simple. Again, I'll clean up the B part there so that I can create space. So in order to calculate, that is B Roman 2, to calculate the number of moles of dilute nitric acid. Now, if you notice in the question, they gave you the volume as well as the concentration of the acid. So the volume was simply the volume, let me just write it down there. So the volume was simply 40.0 cubic centimeters. So right away, divide it by 1000. You remember from my previous video, so that you change to cubic decimeter. So that will give you 0.04 cubic decimeter. Then they also gave you the concentration, which is equal to 2.0 mole per cubic decimeter. But what is the question asking you to find the number of moles? That's what you don't know. So we can apply using the formula for concentration. Remember, number of moles is equal to concentration times volume. So meaning that the number of moles will be equal to, what's the concentration? It's 2.0 multiplied by the volume, which is 0.04. So the number of moles, therefore, when you multiply this, it will give you 0.08 more of what? Nitric acid. So these are the number of moles of nitric acid. So that is what they wanted you to do there. Right, so please keep those two values that we have calculated for the number of moles of each, because in the third question, in the C part, we need that. So that's the way you needed to calculate the number of moles. So that's the number of moles of nitric acid. Let's move on and look at the C part. Okay, so as I look at the C part, I'll clean up this one because I need the balanced chemical equation now. Now, of course, it says determine the limiting reactant. Now, I just want to give you a few ideas. What exactly is the limiting reactant? Well, when we talk about the limiting reactant, very important, in most of the questions, they are going to be asking you to define what the limiting reactant is. But the question is, what is the limiting reactant? Well, the limiting reactant is simply the one that determines the amount of product formed in the reaction. In simple terms, we can say it is a reactant that is completely used up in a reaction. So we can simply say, is a reactant. So is a reactant that is completely used up in a reaction. So it is a reactant that is completely used up in the reaction. Another key point that you need to remember is that it helps to determine the amount. It helps to determine the amount of product formed. So meaning you use this limiting reactant to know any of the product. For example, if I find which one is the limiting reactant, I can use that limiting reactant to know what mass of magnesium nitrate was produced or water was produced. It's the one that will determine that. No wonder, because it determines or limits the amount of product formed, no wonder we simply call it as being the limiting reagent. Well, in my next video, I'll simply talk about this in more detail. But just a few concepts again that you need to remember. When determining the limiting reactant, there are so many ways that you can look at. One, sometimes if you have a reaction, for example, magnesium oxide reacting with what we are calling as being sulfuric acid to produce maybe magnesium sulfate and your H2O in that case. This one is a balanced equation. Now, if you notice the mole ratio of the reactants, if you compare the mole ratio of the reactant, it's 1:1. So when the mole ratio of the reactant is 1:1, please take note of this. If the mole ratio of the reactant is 1:1, then it simply means that you can just determine the number of moles of the two guys. The moment you determine the number of moles of the two guys, the one with the lowest number of moles is the limiting reagent. So I can say when the mole ratio from the balanced equation for the reactant is 1:1, then the one with the smallest moles is the limiting. So it's actually the limiting. I can write that is the limiting reagent. So that's what you need to remember. So when the mole ratio from the balanced chemical equation for their reactants, I'm focusing on the reactant, is 1:1, then it simply means the one with the smallest or with the fewer number of moles will be the limiting reactant. But suppose, for example, you have got a reaction like this one, where we are talking about where you have got hydrogen reacting with oxygen to produce H2O. When you balance up this one, you are going to find, let's look at, you are going to, it's already balanced. When you look at the mole ratio in front, it is 2:1. Well, when the mole ratio is like this, you cannot just assume to say after finding the number of moles that what you have is actually the limiting reagent. No, because the mole ratio is not 1:1, and that's this question that we have there. So there's something that we are going to do, and this is what I want to demonstrate now using this question they have told you. Please watch my next video, then you'll be able to get more concept on limiting reactant, sometimes called limiting reagent. So now, how do you determine the limiting reactant? Well, if you remember, the number of moles that we got for magnesium oxide, after we calculated the number of moles we got for magnesium oxide was simply 0.075 moles, if you remember. And the number of moles for nitric acid that we got was simply 0.08 moles. That's what we got. So what we are going to do now, since we know the number of moles, to help us determine which one between magnesium oxide and nitric acid, which one is the limiting reactant. Mind you, it is the reactant. It has to do with the reactant and not the product. So we are focusing on the reactant. Like I said, there are so many methods. So what I can do from the balanced chemical equation here, how many moles do we have for magnesium oxide? We have got 1 mole. So from the balanced chemical equation, 1 mole of magnesium oxide requires how many moles of nitric acid? It requires 2 moles of nitric acid. So what I'm going to do, I'm going to say, suppose now you can use any. If you want, you can use this or you can use that. But let me just use this one here. So I'm going to say, suppose I have 0.075 moles of this magnesium oxide. Then how many moles of nitric acid do I need? That will help you to know which one is the limiting. So we cross multiply. So it will be x times 1 will give me x is equal to 0.075 multiplied by 2. Well, when we multiply 0.075 times 2, it is giving me my x is equal to 0.15 mole of nitric acid. So look at this, meaning when you react this number of moles, the number of moles that you need for nitric acid is 0.15 mole of nitric acid. Now, do you notice the number of moles that we have for nitric acid? We have 0.08. So the ones that we need when we react this is, I need something bigger because it is 0.15. And what I have there is smaller. So because what you need is bigger than what you have, it simply means that the nitric acid is the limiting reagent. So therefore we can conclude, we can simply say, NHO3 nitric acid is the limiting reactant. So that's what you can do. Watch out for my next video. You'll be able to see more concept actually come up on this one. Thank you so much for listening. See you in my next video.